today's video, we'll look at the understanding of p-value, statistical significance, and how to conduct a simple hypothesis testing. Alright, let's dig right in. First off, we want to look at what p-value is. When we talk about p-value, the P in the p-value stands for probability. It is basically the measure of how likely it is that any observed difference between groups is due to chance or not. So the p-value in this case, if it is less than 0.05, is usually suggestive of a statistically significant difference or relationship, in which in this case we would reject the null hypothesis. We will look at the null hypothesis very shortly. And so you do your study and then you test for a statistical significant association between two groups. And what does the p-value stand for? What does the p-value mean? It usually is testing for the possibility that the relationship that exists between two groups is not out of chance, but rather it is basically as a result of an outcome that comes from that particular association. Alright, we want to quickly look at what a statistical significance means. Normally, it is a statement that claims that a result from data that have been generated from any statistical analysis that you do by testing or experimentation is likely to be attributed to a specific cause and not merely by chance. And so if, for instance, you have student score of a particular class and you want to know if there is a difference between the students who are staying close to the school premises and those who are staying far, you perform a simple statistical test and then you note the mean difference between the individual students. You want to know if their score is not just by chance, or the fact that they are staying near to the school or they are staying away from the school have any form of relation. And so that is where you perform a statistical test to test the p-values and to know if there is any statistical significant difference. Now, if you have a p-value of less than 0.05, what it means is that there is a statistically significant association or difference, like I have aforementioned. But when you find out that there is a p-value of more than or greater than 0.05, then there is no statistically significant association or no statistically significant difference that exists between these two groups. What it means is that if you tested your hypothesis, in this case you will accept your null hypothesis. In the first instance where the p-value is less than 0.05, you would reject or fail to accept the null hypothesis. Talking about null hypothesis, failing to reject, failing to accept the null hypothesis. What at all does it mean? We want to look at hypothesis testing procedure. And the first thing is that you want to state the hypothesis. Now, this is the process you need to go through even before you start the study. When you come out with the objective, you come up with the aim of the study. The first thing, especially if it is an experimental study or a quantitative study, you want to go through this hypothesis testing procedure before you gather your data. And the first thing is that you want to state the hypothesis. In stating the hypothesis, you first of all state the null hypothesis. Null means nothing. And so in stating the null hypothesis, you want to say that there is actually no difference at all, or there is actually no relationship at all. And this statement actually represents what you want to test against. You want to test against the fact that when students stay far from school or when students stay closer to school, it has no relation with the score that is get. That becomes your null hypothesis. So the fact that students are staying away from school or the fact that they are staying closer to the school doesn't affect their results. This becomes your null hypothesis. And the other side of it, or the opposite of it, is the alternate hypothesis. And this is what you actually want to prove. It is the opposite of the null hypothesis. And here you want to prove that the distance or proximity of students to school affect their scores. And so the second thing is that you want to choose a significant level. Now the significant level could be any value below 0.05. You want to reject the null hypothesis. And using the example I just stated, if you get a value below 0.05, then you are saying that indeed the proximity of students as far as the school is concerned affects their results. In this case, we have rejected the null hypothesis. The third thing you want to do is to be able to select the appropriate test. Select the appropriate test. Now, the appropriate test that you want to select. It could be a t-test, it could be a chi-square test, it could be ANOVA, it could be even correlational test or regression. Now, any of these tests that you perform would produce or generate a significant value using the means or proportions of the data set that you have. And depending on your data and the nature of the research question, will determine which type of test you are supposed to choose. And this test is what you are going to use to prove your hypothesis. Select the appropriate test based on your data type. You select the appropriate test also based on the nature of the question. And the data type or the data appropriate test could be t-test, it could be a chi-square test, it could be ANOVA, or what have you. And I'll cover another video talking about which data test or appropriate test you are supposed to choose in conducting your research. And also, if the study or the data type is continuous or categorical, it also determines the type of test you are supposed to choose. For instance, for a continuous data type, you normally perform a t-test or ANOVA. A continuous data type is like height, age, measurement of hypertension, BMI. All these are continuous data type. But for a categorical data type, you will normally choose a chi-square test, okay, in order to test your hypothesis. So the next stage in testing your hypothesis is to collect data and compute the test statistics. After collecting your data, then you compute the test statistics using any of the statistical softwares available, like Stata, R, SPSS, and what have you. You compute your test statistics. After computing your test statistics by gathering the data and making sure it is sufficiently large, then you determine the p-value. If it is greater than 0.05, then you are going to accept the null hypothesis. In this case, for example, using the scores of students and their distance, you are going to say that indeed the distance or proximity of students in relation to their score has no relationship, or there's no statistical difference between students staying afar and students staying close to the school as far as their scores are concerned. But if you found out that the p-value is less than 0.05, then indeed it shows that there is a statistically significant difference between students staying afar and students staying close to the school as far as their scores are concerned. In this case, you are going to reject the null hypothesis. The last procedure is to make a decision, rejecting the null hypothesis or accepting the null hypothesis. And that would be in respect to the p-value that you get. And I've already talked about the fact that if the p-value is less than 0.05, we reject the null hypothesis. If the p-value is greater than 0.05, we fail to reject the null hypothesis or we accept the null hypothesis. Now with this, you should be able to explain your p-values in relation to your data points. You should be able to make your statistical significant statement and its subsequent interpretation as far as your results is concerned. And you should be able to test your hypothesis and draw conclusions as to whether there is a statistical significant association between two data groups or not. And if you're able to do so, then you report your findings for us to know how your results came about. All right, thank you for watching this.